Hi, Assalamualaikum and a very good morning. So now we are in chapter 4, chemical bonding, and now we are in the subtopic of 4.2 molecular shape and polarity, part 2 of the video. So in this video, we're going to learn on how to predict and explain the shapes of the molecule and bond angle in a given species by looking into the example. So we're going to look about this in the part 2 of the video. For the learning outcome of A and B, we have looked about that in the previous video, which is in part 1. So without any further ado, let us start with part 2 of the video first. So in this previous video, you have learned about the idea of VSEPR and also various molecular shape. So according to the electron pair, you're going to have a various number of the linear or basic shapes, for example, linear, trigonal planar, tetrahedral, trigonal bipyramidal, as well as the octahedral. Let's say for electron pair number 3 here, you can adopt a structure of trigonal planar when all the terminal atom is in the bonding pair. And when the molecule has one lone pair and two bonding pair, then it will going to adopt the structure of pen. So this slide here will be very, very helpful to us in order to determine the correct shapes. And we're going to look into on how we can draw the Lewis structure and predict its shape by looking into the various examples. So in this video, we're going to learn on how to identify the class of the compound, almost similar to what you have learned in the previous video. And then we're going to use the VSEPR theory in order to predict the molecular shape. So in order to draw the molecular shape according to VSEPR, we need to be able to draw the Lewis structure of the molecule and calculate the formal charge in order to make sure the structure that we are drawing is stable. So once you get the correct one, we need to identify the class of the compound, and then we need to predict the shape using VSEPR. So let us look into the example. So using the VSEPR theory, we need to predict the molecular shape of this ion. So we have carbon dioxide as well as we have the boron trifluoride here. So for carbon dioxide, as what we have did in the previous videos, we need to find the total number of valence electron first. So carbon will have 4 electrons. 2 oxygen means that 2 times 6. So we're going to have 12. So 4 times 12, 4 plus 12 going to be 16 electrons. So between carbon and oxygen, carbon going to be the central atom and it is bonded with 2 oxygen. So we have used up 4 electrons. So we're going to left with 12 electrons. So the 12 electron will be used in order to completely fill the terminal atom so that it is octet. So we have 6 on the right hand side and then 6 on the left hand side. So minus 12. So we have used up all the electron. Okay, and now we need to ensure that the central atom here to be octet. So what we're going to do is we're going to bring one lone pair so that it can make another bond here so that it can form a double bond. Similarly on this side here. Okay, so we're going to get to be something like this, which is C double bond O, C double bond O, and then 2 lone pairs. Okay, so you can choose any of the lone pairs. Okay, and from this structure here, you need to ensure that your charge is stable. So in order to do that, we need to calculate the formal charge. So we can start up with the carbon first. So carbon will have 4 valence electron, but it does not have any lone pairs. So minus 0, and then it have 1, 2, 3, 4, minus 4 bonding pairs, and it is equal to 0. For the oxygen, we know that the oxygen will have 6 valence electron, minus lone pair electron, which is 1, 2, 3, 4. Okay, minus bonding pair 1 and 2. So minus 2. So the formal charge here going to be 0. Okay, and this oxygen here and the oxygen here is the same. So 0, 0, and 0. So this structure here are basically stable. Okay, so once you have done with step number 1 and step number 2, you need to identify the class of the compound. So from here, you know that C, the center here is like A, and then it is connected with B and B, which is the terminal atom. So you know that it is a class of AB2 because the double bond here refers to one electron pair. The double bond here is also referred to a one electron pair. So whether it is single, double, or triple, but since it is connected with one terminal atom, so you only consider it as one. Double also you consider it as one electron pair. Here you also consider it to be one electron pair. So we're going to have AB2 because we have like this 1 and 2 bonding pairs. So the class of our compound going to be AB2, and if you were to look at here, AB2, it's going to be linear shape. So we can put the linear here. So the class going to be AB2 and the shape going to be linear. So you know that the structure that you are drawing here is correct. So you can draw it again and then completely fill the electron so that it is octet. So here and here is basically the same for this case. Kebetulan sama. Okay, now we're going to do another example which is BF3. So BF3, you need to count the total number of valence electron. So boron going to be 3 electron. Fluorine is 3 fluorine, which is 3 times 7, which is 21. So 3 plus 21 going to be 24 electrons. So this one is correct. So boron and fluorine, boron is the most electropositive, more electropositive in comparison to fluorine. So boron going to be the center, and then it is bonded with 3 fluorine atom. So we have used up 2, 4, 6. So minus 6 electron. So we're going to have with 18 electron. So 18 electron here will be used up in order to make the structure octet. So 6, 12, 18. Okay, so all the electron has been used up. Okay, so for the starting part here, it is okay to draw in whichever way that you want. Okay, and to ensure that your structure here is correct, it is advisable to calculate the formal charge. So for the formal charge of boron, you can calculate it by the valence electron of the boron is 3 minus 0 lone pair minus 1, 2, 3 bonding pair. So the boron have a charge of 0. For the fluorine, here, here, and here is identical, so you can only calculate a one type. So the valence electron of fluorine is 7 minus 1, 2, 3, 4, 5, 6 lone pair electron minus 1 bonding pair. So the formal charge of fluorine is 0. So 0 at all terminal atom. So you know that your structure here is correct. However, this is not the molecular shape based on VSEPR. So you need to draw the correct shape based on the 3D arrangement. So in order to do that, we need to identify the class of the compound first. So you know that it has 1, 2, 3 bonding pair. So it's going to be AB3 here. And as what you can see here, AB3, so you can refer to the previous page if this one is too small for you. So AB3 here refers to a trigonal planar. So we need to draw it in terms like a fidget spinner. So AB3 is a trigonal planar. And then we need to draw it like a fidget spinner. So A, B, B, and B. So we're going to copy the structure again, but make sure it has the shape of like this, which is 120 degree between one bond to another. Okay, so it's going to be something like this. And don't forget to fill in the electron so that it is octet, similar to the what that you have drawn. Okay, so this is the structure that is accepted by VSEPR. Now we're going to do more example. For example, for the ammonia here. So similar thing, we need to find the Lewis structure and calculate the formal charge first. So nitrogen going to have 5 electron, 3 hydrogen, so means that it has 3 times 1 electron. So the total going to be 5 plus 3, 8 electron. So the nitrogen going to be the central atom. because hydrogen cannot be the central, it always be the terminal. So it connected with 3 hydrogen. So 1, 2, and 3. So 6 electron. So we have balance 2 electron. So the 2 electrons supposed to be filled at the terminal. Patut diisi dekat terminal. Tetapi since terminal kita hydrogen, dia sudah doublet. Okay, so dia sudah stable, and hence the 2 electron will be filled at the center atom. So it's going to become like this. Okay, and to ensure that you have drawn it correctly, you can calculate the formal charge. So for the formal charge of nitrogen, the valence electron going to be 5 minus 1 and 2 lone pair electron minus 1, 2, 3. So the formal charge of nitrogen is going to be 0. And then you can calculate the formal charge of the hydrogen. So this hydrogen, and this hydrogen are identical. So you can just calculate it one time. So the valence electron of hydrogen is going to be 1 minus 0 lone pair minus 1 bonding pair. So minus 1. So you know that the charge is going to be 0. So you're going to be 0, 0, 0, and 0 here. So you know that the charge, the structure here is stable. However, this is not the best shape according to VSEPR, because according to VSEPR, we need to make sure that the bonding is far apart from one another to ensure that it is stable, okay, in order to minimize the repulsion. So the thing that we're going to do is we need to identify the class of the compound. So from here, you know that the class going to be A, which is representing the central atom. And then we have 1, 2, 3 bonding pair. So it's going to be B3 and then 1 lone pair. So it's going to be AB3E1. Okay, so 1 is optional to you. You want to write it or you don't want to write it is also okay. So you can put it as B3 or AB3E. So you know that B3E refers to 4 electron pair. Okay, so you look at here, electron pair ada 4. 3 campur 1. Tetapi dia bukan kesemuanya bonding pair. Dia 3 bonding pair and 1 electron pair. So it's going to adopt the structure of trigonal pyramidal. So it's supposed to look something like this. A, B, 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 and then something like this. So you need to draw it according to its shape. Okay, so AB3E, and the shape name going to be trigonal pyramidal. So now we're going to transfer this shape into the correct shape, which is to be looking something like this. So it is the same as what you have looked into the summary in the previous video. Now we're going to look into the next example, which is H2O. So for H2O, we need to find the valence electron first. So 2 hydrogen going to be 2 electron. Oxygen going to be having 6 electrons, so 8 valence electron altogether. So oxygen going to be the central atom, and then we have connected with 2 hydrogen minus 4 electron, and then we have valence 4 electron. So the 4 electron here supposed to be filled at the terminal, tapi terminal kita sudah stable because they are the doublet electron arrangement for hydrogen. So the 4 electron going to be placed in the central atom. So 2 electron here and 2 electron here. And then to be sure that our drawing is correct, we can calculate the formal charge. So the formal charge of oxygen going to be the valence electron of oxygen, which is 6 minus 1, 2, 3, 4 lone pair electron minus 1 and 2 bonding pair. So the charge of oxygen going to be 0. And then for hydrogen, 1 minus 0 minus 1, so it's going to be 0 here. So you know that the structure is stable. However, this is not the best drawing according to VSEPR. So in order to do that, we need to identify the class. So for the water here, the class going to be A, which representing a central atom. It has 2 bonding pair, so it's going to be B2, 1 and 2, and then it has 2 lone pairs, 1 and 2. So going to be AB2E2. So the number of electron pair going to be 4, So you look at here, electron pair 4, but now it has a structure of AB2E2, the class of AB2E2, which is, it refers to the band. So kita mesti lukis dalam bentuk band ataupun V shape. Hence, we can draw it to be O, H, like this, and then like this. So it is consistent with what we have seen. Okay, so we're going to draw it in terms of like this. Okay, now we're going to look into the next example, which is the ClF₃. So similarly, the same process as before, calculate their total valence electron 7. 3 fluorine means 3 times 7, 21. So 7 plus 21 going to be 28 electron, which is the same as here. So Cl going to be the central atom because Cl is more electropositive than fluorine. So Cl bonded with 3 fluorine minus 6 electron. So we're going to have 22 electron. And then the 22 electron is used to complete the octet at the terminal. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have used up 6, 12, 18. So we're going to have 4 electron left. So the 4 electron can be filled into the center, 1, 2, and 1 and 2 here. Okay, so the structure that you're going to get is to be something like this. And you can double check by calculating the formal charge so that you have the lowest formal charge and you know that it is stable. So for the formal charge of chlorine, it has 7 valence electron and then it have 1, 2, 3, 4 lone pair electron minus 1, 2, 3. So the charge here is 0. And then for fluorine, so here, and here is the same, right? So you just calculate it one time. 7 valence electron minus 1, 2, 3, 4, 5, 6 minus 1 bonding pair. So it's equal to 0 as well. So you know that the charge is consistent and it is stable. So in this case, it may not be the best VSEPR structure. So what you need to do is you need to identify the class of the compound. So you know that it has 1, 2, 3 bonding pair. So it's going to be A representing the central. B bonding pair ada 3 kan? 1, 2, 3. Lone pair 1 and 2. Pasangan 1 and 2. So it's going to be AB3, E2. So the total number of electron pair that we have, 3 plus 2 going to be 5, right? So you look into the section here, 5 electron pair, AB3E2. So dia sepatutnya ada T-shape punya structure. So it's going to be a T-shape shape. Hence, we're going to draw it in terms of T-shape, which is something like this. Nampak macam bentuk T. Ataupun, if you want to maintain the structure here, it is also acceptable because it's still looking like a T-shape. Okay, so kebetulan the structure that you have drawn earlier is the same as the VSEPR theory. So this one is acceptable and this one is also acceptable. Okay, so now let us look into the last example, which is iodine 3 minus. So 3 iodine going to be 3 times 7 electron, which is 21. And then we have minus 1, which means that we receive another electron. So we have to plus 1. So we have 22 electron. So iodine going to be the center because it's the same species. So iodine, iodine, and iodine minus 4 electron. And then we have 18 electron altogether. And then we need to fill the octet 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So minus 12 electron. So we have valence 6 electron. So the 6 electron going to be filled 1, 2, 3, 4, 5, 6. So we're going to be looking something like this. Okay. And then to double check, you can calculate the formal charge. So the iodine here, which is iodine A, and iodine C here is the same. So Ia is equal to Ic, which is 7 valence electron of the iodine minus 1, 2, 3, 4, 5, 6 minus 1 bonding pair. So it has a charge of 0 and then a charge of 0 here. And then for the central atom, Ib, I label it as B here, their valence electron going to be 7 minus 1, 2, 3, 4, 5, 6 minus 6, and then 2 bonding pair, 1 and 2. So the charge that I'm going to carry is minus 1 here. So minus 1 here, you know that the summation of formal charge, yang mana bila summation kosong campur negatif 1 campur kosong, the charge going to be negative 1, which is consistent to the charge of the polyatomic ion. So you know that it is correct. Okay, and as usual, we need to identify the class where we need to look at the central atom. Okay, so you're gonna have A, which is representing central, and then it has 2 bonding pair, which is AB2, and then it have 1, 2, 3 electron pair. So it's gonna be AB2E3, and AB2E3 here, you know that it refers to here. Dia masih 5 electron pair, tetapi 2 bonding pair dan 3 lone pair. So it's supposed to have a shape of the linear. So secara kebetulannya, what we have drawn just now is the same as the VSEPR. So you can copy back again and put it in terms of vertical here. So you can put it to be the same as before. Bracket negative, or you can also make it a vertical here. So both of these answers here are accepted because this shows a linear shape and this is also shows a linear shape. Okay, so I think that's all for today's video. See you again some other time. Bye.